Mean absolute deviation. MAD. Biohazard. Yeah, some weird stuff. It's not the end of the world, though. It just sounds ridiculous. So, I mean, what does it mean? It's the average distance between the average of data points. I mean, kind of self-explanatory. Let me break that down a little bit more. Find the mean or the average of the data. Okay, so you're going to have a list of numbers. You're going to add them up and then divide by how many numbers you added. Get the average. Then you're going to find the distance each of those points from the original data is from the average. So if your average was 5 and you had a data piece that said like 7, it'd be 2. And then you'd start recording that. Then you'd find the average of those numbers. So what you're doing is you're finding the average distance the data is from the average. The closer the numbers are to the average, that means you're going to have a smaller mean absolute deviation. Deviation is how far something is away from something. A deviation's change. Absolute is going to be the absolute value from the first average you get. And then mean is the average distance from the first average and how much it's changing by. So a large MAD would mean that you have data that's not necessarily clustered together. So they're all kind of far apart, and you'd be able to get that measurement of how far apart they actually are by using mean absolute deviation. If you had a small mean absolute deviation, that means you have a cluster of information all together. So we're going to go through the 3 steps. I'm going to show you just how straightforward and simple it is. It's just, it's a task for sure. There's not any getting around that. All right, so I have a calculator. I'm going to do 3 plus 1 plus 5 plus 4 plus 8 plus 6. And here is something that you don't want to end up doing twice. Anytime that you're messing with a data set, you want to put it in order from least to greatest. And it'll save you time for whenever you get into central tendencies. Central tendencies is your mean, median, mode, and range. Went ahead and added all these up, and I got 27. So I'm just going to put positive 27, okay? And I'm going to divide that by, looks like 1, 2, 3, 4, 5, 6. 4.5. Okay, so the mean's 4.5. That's what I'm writing for all of these because this is the thing that we're going to be finding the difference between. And keep in mind it's absolute value. So there's not going to be any negative values. It's just the distance from the mean. So to find the difference between them, 4.5 minus 1 would be, the difference would be 3.5. 4.5 and 3 distance is 1.5. 4.5 and 4 is 0.5. 4.5 and 5 is 0.5. So you can see the 4 and 5, they still have the same difference. That's where the absolute part comes in, the distance from the mean, not necessarily positive or negative. 6 and 4.5 should be 1.5, and 8 and 4.5 should be 3.5. So now we take all of those differences. This is step 2. Actually, no, this is step 3. Step 1 was we found the mean, which was 4.5. I'm going to color code this stuff. Okay. And then number 2 was we found the difference. Number 3 is going to be us. Oh, that's supposed to be purple. That's supposed to be purple. Number 3 is us finding the absolute value Okay, so the difference is 3.5. Add all these up, 1.5. That's 11, and then divide it by the 6. 1.83 repeating. Okay, so the reason that this is saying the difference was because you have 1 minus 4.5, they give you negative 3.5. I went ahead and skipped that because all you're going to end up doing is writing it right here as an absolute value. So I'm just going to rewrite those because that's what I just added up. That came out to be 11. And then I divided it by 6 and got a mean absolute deviation of 1.833 repeating. Not crazy, but the process is kind of ridiculous. So if this were like 10.83, then that means that the numbers are farther away from the mean in step 1. Let's get that down first.